Industrial automation, a transformative force within the modern world, has redefined how industries operate by harnessing the power of technology to streamline processes, enhance efficiency, and reduce human intervention in repetitive or hazardous tasks. This field integrates a spectrum of advanced systems, including robotics, artificial intelligence, AI, sensors, and control mechanisms, to create seamless workflows that have revolutionized manufacturing, logistics, and other industrial sectors. As automation continues to evolve, its impact reaches far beyond productivity, shaping economies, redefining job roles, and paving the way for innovative possibilities. At its core, industrial automation replaces manual labor with mechanized systems designed to perform tasks with speed and precision. These systems can be as simple as conveyor belts and assembly lines, or as complex as robotic arms capable of intricate movements. Automation thrives on repeatability, ensuring that operations are executed consistently, regardless of the time of day or environmental conditions. This reliability has become indispensable in industries where accuracy and efficiency are paramount, such as automotive manufacturing, pharmaceuticals, and electronics assembly. The advent of programmable logic controllers, PLCs, marked a significant milestone in industrial automation. These compact devices serve as the brains of automated systems, enabling machines to respond dynamically to changing inputs. For example, in a bottling plant, a PLC can monitor sensors to ensure that each bottle is filled to the correct level before capping it. PLCs epitomize the flexibility of automation, as they can be reprogrammed to adapt to different tasks or production requirements. This adaptability underscores one of automation's key advantages: its ability to evolve alongside industry demands. Robotics has emerged as a cornerstone of industrial automation, redefining what machines can achieve. From pick-and-place robots that handle materials with precision to collaborative robots, or cobots, that work alongside humans, robotics has expanded the scope of automation. Cobots, in particular, highlight how automation and human labor can coexist symbiotically. Designed with safety features such as force sensors and collision detection, cobots assist in tasks requiring dexterity or decision-making, enhancing overall efficiency while reducing physical strain on workers. This partnership underscores the evolving narrative of automation as an enabler of human potential rather than a replacement for it. Sensors and data acquisition systems play a pivotal role in modern automation, enabling machines to monitor their environment and respond intelligently. Sensors collect data on variables such as temperature, pressure, and movement, feeding this information to centralized systems for analysis. This real-time feedback loop facilitates predictive maintenance, where potential equipment failures are identified and addressed before they escalate. The integration of sensors and analytics embodies the principles of Industry 4.0, the current phase of industrial evolution, characterized by interconnected, data-driven systems that enhance decision-making and efficiency. Artificial intelligence and machine learning have propelled industrial automation into uncharted territories, enabling systems to learn, adapt, and optimize processes autonomously. AI algorithms analyze patterns and data to uncover inefficiencies or predict future trends, allowing industries to make proactive adjustments. For instance, an AI-powered quality control system can identify defects in products with accuracy surpassing that of human inspectors, ensuring consistency and reducing waste. The fusion of AI with automation has led to smart factories, where interconnected machines communicate and collaborate to achieve unparalleled levels of performance. The rise of automation has significantly impacted supply chain and logistics operations, where speed and accuracy are critical. Automated warehouses, equipped with robotic picking systems and autonomous vehicles, exemplify how automation streamlines inventory management and order fulfillment. These systems can work around the clock, ensuring rapid delivery times and meeting the demands of e-commerce. Additionally, technologies like automated guided vehicles, AGVs, and drones have revolutionized material handling and last-mile delivery, further enhancing operational efficiency in the supply chain. Safety is another dimension where automation has made remarkable strides. In industries such as mining, oil and gas, and chemical manufacturing, hazardous environments pose significant risks to human workers. Automation minimizes these risks by deploying remote-controlled machines or fully autonomous systems to handle dangerous tasks. For example, robotic arms can operate in environments with toxic chemicals, while drones conduct inspections in confined or elevated spaces. By safeguarding human lives, automation redefines workplace safety and opens new possibilities for operating in challenging conditions. Despite its numerous advantages, industrial automation has also sparked debates about its implications for the workforce. As machines take over repetitive or labor-intensive tasks, concerns about job displacement have emerged. However, automation also creates new opportunities, particularly in roles requiring technical expertise to design, program, and maintain automated systems. The emphasis has shifted towards reskilling and upskilling the workforce to adapt to changing demands, highlighting the importance of education and training in ensuring a harmonious transition to automated workflows. The environmental impact of automation is an area of growing interest as industries seek to align productivity with sustainability goals. Automation can optimize resource utilization, reducing waste and energy consumption. For instance, automated systems can monitor energy usage and adjust operations to minimize carbon emissions, contributing to greener practices. Additionally, precision in manufacturing processes ensures that raw materials are used efficiently, further reducing environmental footprints. These advancements position automation as a key player in fostering sustainable industrial growth. As technology advances, industrial automation continues to evolve, integrating emerging trends such as the Internet of Things, IoT, 5G connectivity, and blockchain technology. IoT enables machines to connect and share data seamlessly, creating networks that enhance coordination and monitoring. 5G connectivity supports the real-time exchange of information, enabling faster and more reliable communication between devices. Blockchain technology, with its ability to ensure transparent and secure transactions, holds potential in enhancing supply chain traceability and accountability. These innovations represent the forefront of automation's journey, promising new horizons for industries worldwide. Ultimately, industrial automation encapsulates the spirit of innovation, redefining how industries operate and interact with their environments. From enhancing productivity and safety to fostering sustainability and technological advancement, automation stands as a testament to human ingenuity and adaptability. As industries navigate the complexities of an automated future, the collaborative efforts of technology, workforce, and society will shape the trajectory of this transformative field, ensuring that its benefits extend to all facets of human endeavor.